Okay. So first we're going to take the cap off of the bottle and remove the cap, remove the bottle but keep the cap on. And then we're going to wash it off with the wash bottle and the waste beaker and wipe it off. And now we're going to go on here. I'm going to press calibrate. Alright, so after you press calibrate, we're going to press calibrate now. And then place it in the pH 7 beaker. And then since it's pH 7, we're going to put 7.0 and press keep. Now we're going to wash it off, just like we did the first time. And wipe it off. And then we're going to do the same thing but in the pH 4. And we're going to put in 4.0 and press keep. And then okay. And now you can see that it says 4 here. And if we wipe it off again, we can put it in the 7 and see that it will go to 7.
Oh. Okay, here's what I'm doing. Taking this, still water. I'm going to rinse this off, like so. We're going to take us a nice little wipey. We're going to wipe it off. Alright. And then I'm going to take this and I'm going to put it in the OJ to get the pH of that. And it's going to record it on here when it stops moving. And there it is. Oh, well, it's still going. Come on. Okay, 4.63, the clever stopping it. Okay, we're taking that. Wipe this off again. Put it in here. And then I'm going to record the data for the orange juice at... and we're done.
Oh. Alright, so the buffer solution is a weak or a weak acid or base, which is also with its pairing, and it's used to calibrate the pH meter without affecting the pH too much of the substance being taken. So since the weak buffer is a weak acid or base, it's not going to dissociate well and affect the pH.
Yep.
Alright, so we're going to calculate the concentration using the pH by doing 10 to the negative whatever the pH value is. So 10 to negative 5.3 to get this beautiful number right here. Alright, so we repeated the steps that we did in the apple juice for each solution, and this is our data.
Okay.
Alright, so to clean the pH meter, we're going to clean it off one last time with the water and then wipe it off. And slide the cap back on over top of the water bottle. And then we're going to unplug it from the LabQuest and go put it back in the bucket.
Alright, so strong acids dissociate completely due to common intermolecular forces, but weak acids do not dissociate as well because, for example, acetic acid only dissociates about 5% of their molecules when mixed in solutions. So strong acids have a low K value because they dissociate so well, so they can reach it faster, equilibrium a lot faster. And to minimize the effect of that, you can minimize the effect of it by diluting the concentration of the acid, or
And I'm cleaning up our lab station.
Yeah.
We did great.
Clean it.
Okay, I'm sorry.
also exercise 3.
I hate you. After you finish your don't throw a basketball outside.